black shales actually represent when the marine transgression got the deepest. And there's a lot of dark color. That's actually organic material. So organic material is raining down from above in the seawater, but the water's gotten deep enough that the bottom water is actually anoxic. There's no oxygen. So there's nothing living on the bottom of the ocean, and so there's nothing burrowing through it. So you have facility, you have laminations that don't get disrupted. And a lot of rocks, you don't get these laminations because organisms that are burrowing through the sediment will destroy that and mix it all up. But when it's anoxic like this, there's nothing living in the sediment, so when it's deposited, it forms these sort of really thin, what we call fissile layers. Very organic rich, and it takes a long time for some of these shells to deposit because as the seas transgress over the landscape, you're moving deposition landward, and so there's less sediment actually working out to this part of this area, so it takes a long time to build up even like a really thin shell. But things are dying and depositing, and over time that builds up, so you get a lot of fossil material in these really thin shells, and we get what we call condensed sections. So this represents the maximum transgression, or the deepest water level that you achieve in these cycles. We call these cyclothems, and cyclothems are repeated packages of non-marine and marine rock, and they're repeated hundreds of times over the Pennsylvania. You were going to say something? Or?
If it's time.
Yeah. Well, do you have anything to add?
Sure. I was in this quarry sometime around 40 or so years ago when I'd come up from the Kansas Survey, and it was a real small quarry right up there. It's expanded over a couple of square miles now, it looks like. And I was in here with a student once, Steve Shutter, and he worked on the Stark Shale and the Galesburg Shale as part of his thesis, and we looked at this Davis City coal, and then he named it in his thesis, the Davis City coal. And another thing I'd mention is that the organic matter in the deep water shales, these two here, are the pelagic organic matter that you get from phytoplankton and that sort of thing in deep seas, well, deep for the craton, maybe 100 meters, on the order of a couple hundred feet. And then the organic matter that you get in the coal are the vascular plants that live on land. And all you need is a low oxygen environment, as Tom said, and these are the swamps that are preceding the transgression that's coming in.
Right.
The sea level rises, raises the water table, and then sometimes in low areas on the topography you'll get a swamp before the sea covers it over. But when the sea gets really high, then you get into these, as Tom pointed out, laminated black shales, no burrowers, the oxygen's too small. And this is typical of this type of thing, and we refer to these dark shale, particularly this sort of thing, that are flat and top and bottom. Those are hockey pucks. See, and so when you go in a core and you find your hockey pucks, and then you can see these little light laminae in there, which usually are phosphate, then we know we're in the deep water stuff. Another thing, there's different kinds of fossils throughout this. You'll sometimes get the terrestrial plant fossils around this horizon here, because that's the shoreline. And you go up through here, and you go up through, sometimes you'll get fossils that were occurring in the deepening waters. And then they got anoxic, so there's no more bottom fossils here, but you have these fossils that are now extinct. They're known as conodonts. And they were little vertebrates that, not vertebrates, chordates that
well, they could be basal vertebrates. Well, okay, good.
They don't have a backbone. What you get is their teeth, and they're phosphate. They're the exact same composition as our teeth, and they're microscopic. And these conodonts evolved up through the succession, and we get a first appearance of one form or two forms in here, and then we get another first appearance forms in here, and then there's another shale up above that you'll see in the next quarry, the Quivira. Another group of forms come in there, and a lot of the work I've done since I worked on this for the Kansas Survey, and then published a bunch of papers when I was here on what recently, what I've been doing in conjunction with Jim Barrick at Texas Tech University, who's also a graduate of Iowa, he's identifying and naming all these conodonts if they hadn't all been ready named, and he's sorting out all the names that have been given to him many, many years ago. And we've got to the point now where we can correlate this marine transgression, not only all the way from Omaha to Des Moines to Kansas City to Tulsa, but we can correlate it with a succession in Texas, the succession in Illinois where they call it the Macoupin, and most recently with a succession in the Appalachian area where this is the Lower Brush Creek, or Brush Creek of Pennsylvania, Lower Brush Creek of Ohio. And the same with this one. And you can trace that all the way down and correlate it with the section in Texas, and again through Illinois. This is the Upper Brush Creek of Ohio, or the Pine Creek of Pennsylvania. So we're still working on that, and we were able to, in conjunction with Russian and Ukrainian geologists, we have now correlated by a few of the conodonts that are in these are common to the areas in Eastern Europe.